In this segment, we'll go through a sample calculation. So we have, we'll see here, we've already met our guest, the pangolin, and I will tell you that there are 8 species of pangolin that live in a variety of lifestyles. And some live on the ground, some live in trees, but they're largely insectivores, meaning they eat insects. They live throughout Southeast Asia, Indonesia, India, and in Africa. There are 8 different species of them. So the largest of the pangolin species lives in Africa and can grow up to 27 kilograms, which you should probably be thinking in your head, how can I estimate its weight in pounds? Well, we would just take that 27 and multiply it by 2, so about 54 pounds. Pretty sizable creature. It's a little bit more than 54 pounds, so maybe closer to 60 pounds. So in any case, we did a quick calculation to see how big that is, since we're not used to thinking about kilograms. So now we have this large pangolin. It climbs up a tree to a height of 3.25 meters. What amount of gravitational potential energy does it gain when it climbs up that tree? Well, we could start with our gravitational potential energy formula. The mass is 27. We use our complete value for g and our height, 3.2. And we multiply those out, we get an unrounded value of 847.29456. So now we have to decide, how are we going to round this? Well, the 27 has 2 digits, our constant has 6, and the 3.2 has 2 digits. So we can only express this to 2 digits. The 7 would cause the 4 to round up, which gives us 850 joules. So that's the biggest part of doing the calculation. The icing on the cake here is for us to express it correctly in terms of how well we know it. Now, we can only express 2 digits, but if we write 850, we know that all scientists write a number such that the rightmost digit is where the uncertainty is. But that is not true. The uncertainty is in the 5. So if we write 850, we are lying. So how do we express the number 850 to 2 significant digits? Well, we express it in scientific notation, which means we move the decimal place over 2, which gives us 8.5. And how we convert 8.5 into 850 is multiplying it by 10, or 10 squared. So this is the final correct answer that tells everyone in the world that this is where our uncertainty is. We have 2 digits in our answer. We know how big it is. For that reason, this number here, 8.5, has a name, and it's called the significand. In a math class, a teacher might call it the coefficient. But its more correct name in scientific circles is the significand. That's a way of telling us that number, all the digits are significant. And we can read it the way that scientists write their numbers. Now, we know there's another way we could have done this calculation. This is the simplest process to use, the one I just showed you. You could always use it, and you don't have to do too much thinking. But we could go about this calculation to use a different number of g. Since we know this one has 2 digits and this has 2 digits, well, the guideline is that whenever you're using a constant, make sure you use at least one more digit than the other data. So this has 3. When we then multiply that out, we get 847.584. And you'll notice that's a fairly different number than this. But since these numbers only have 2 digits, we have to round it to 2 digits. So it again rounds to 850 joules, and expressing it in scientific notation, we get exactly the same answer. So the difference between doing it these 2 ways is simply how many digits of g do we use. But this will yield the same exact answer. Now, that won't always be true, but it is in this case that the 2 will yield the same answer. Now, the other way that is very common and popular to use is just simply use the number 10 for g. Now, this number has 2 digits, this number has 2 digits, and you might look at 10 and say that it has 1 digit. But it really, what we're doing when we use the number 10 is we're rounding to the nearest 10. and there's 110. So this really only has one significant digit. We do the math out, and we find out we get 864, which is quite a bit different. Quite a bit different than 847, 848, or the 850 we would round it to. So expressing this to one digit really would put us with an energy of about 900 joules. And technically, if we were to use this, whenever we use 10, we're not actually calculating a value, we're getting an estimate of the true value. And that's why we use approximately equal. So it's about 900 joules.